The next of the anti-aging 8 is caloric restriction. 3 meals a day plus snacks is an evolutionarily novel behavior. In c.nf/fasting, I review how the story of life on Earth is a story of starvation. If our physiology is so well tuned to periodic scarcity, maybe it would be beneficial to cut back. Beyond just freeing up all the resources that would normally be used for nutrient digestion and storage, during fasting, our cells switch over to a protective mode that results in a reduction of free radical damage and inflammation. It's the hormesis concept of that which doesn't kill us makes us stronger. This was perhaps most starkly demonstrated in a set of cringe-worthy experiments in which mice were blasted with Hiroshima-level gamma radiation sufficient to kill 50% of them within 2 weeks. But of the mice that had been intermittently fasted for 6 weeks before the radiation blast, not a single one died. A time to fast. Benjamin Franklin said, "To lengthen thy life, lessen thy meals." Might this hormetic bolstering of defenses result in a longer life? Using caloric restriction to slow aging became a topic of interest during the Great Depression in the 1930s when, contrary to expectations, average lifespan appeared to increase. The same was noted earlier during World War I in Denmark when blockaded food supplies were accompanied by a 34% reduction in death rates, and later in Norway during World War II when a 20% drop in calories was accompanied by a 30% drop in death rates. The quality of the diets changed as well, though, complicating the picture, with a switch to eating feed crops like barley rather than the livestock to which they were being fed. In the lab, caloric restriction without malnutrition is one of the most powerful non-pharmacological interventions for extending health span and lifespan across a multitude of species, considered perhaps, quote, the most important discovery in the biology of aging to date, unquote. Simply reducing food intake can double or triple the lifespans of yeast, fruit flies, and worms, and prolong the average and maximal lifespans of rats and mice by up to 50%. The experiments can be as simple as feeding some flies to some spiders, cutely named bowl and doily spiders, 1 fly a week, and they live an average of 81 days. 3 flies a week, and they live only 64 days, and 5 flies a week, only 42 days. The animals in some of the experiments live not just longer lives, but healthier lives. The apparent slowing of the aging process conserved up through primates is accompanied by resistance to a range of age-related diseases, preventing or delaying autoimmune diseases, cancer, cardiovascular disease, glaucoma, kidney disease, and neurodegeneration. In Part 1, I covered many of the theoretical underpinnings to the longevity benefits of caloric restriction, from boosting AMPK to cleaning out the cupboard's autophagy, clearing out misfolded proteins, damaged cell structures, and senescent cells. As one review on the mechanisms by which intermittent fasting benefits cardiometabolic disease was titled, "The Janitor is the Undercover Boss." The candle that burns twice as bright burns half as long. Another potential mechanism may be the slowing of our metabolism. Because of our millions of years of evolution hardwiring us to survive scarcity, when we start losing weight, in addition to unconsciously starting to move less as a behavioral adaptation to conserve energy, there are metabolic adaptations as well. Every pound of weight loss may reduce our resting metabolic rates by 7 calories a day, though a bane for dieters. Check out c.nf/biggestloser. A slower metabolism may actually be a good thing. Caloric restriction can increase the lifespans of animals, and the metabolic slowdown may be the mechanism. This may be why the tortoise lives 10 times longer than the hare. Harriet, a tortoise evidently collected from the Galapagos by Charles Darwin in the 1830s, lived until 2006. Slow and steady may indeed win the race. One of the ways our body lowers our resting metabolic rate is by creating cleaner burning, more efficient mitochondria, the power plants that fuel our cells. It's like our body passes its own fuel efficiency standards. These new mitochondria appear to create the same energy with less oxygen and produce less free radical quote-unquote exhaust. After all, our body is afraid that famine is afoot, so it tries to conserve as much energy as it can. The largest caloric restriction trial to date found both metabolic slowing and a reduction in free radical-induced oxidative stress, both of which may slow the rate of aging. The metabolic slowing from eating nitrate-rich vegetables may be why eating leafy greens has been found to be among the 6 most powerful things we can do to potentially live longer. Whether restricting calories will translate into greater human longevity is an unanswered question. Caloric restriction has been said to extend the lifespan of quote-unquote every species studied, but that isn't even true of all the strains within a single species. Strain for effect. If rodent results could be replicated in humans, what kind of life extension might people expect? Well, a 50% lifespan increase would extend the current U.S. life expectancy from 77 years to around 115. But that's based on experiments that restricted food intakes between 40 and 60% starting immediately after weaning. See a full chart in c.nf/extrapolate, but even cutting down one's intake from 2,500 calories a day down to 1,750, a 30% drop, for a few decades starting in one's 40s could potentially add a few years to your life. Same for reducing caloric intake just to 2,125 starting in one's 30s. Again, though, this is assuming we can extrapolate from rodents to humans. A study of more than 40 strains of mice found that caloric restriction shortened the lifespans of 3 times as many strains as it extended. Cutting food intake by 40%, one of the most common experimental regimens, extended the lifespans of 5 strains of mice, shortened it in 15, and had no significant effect on the majority. In one strain, the longevity of female mice was increased while that of male mice was decreased. If we can't even extrapolate the effects of caloric restriction from one strain of mouse to another, how can we extrapolate from mice to men or women? I explore other problems with generalizing results to humans in c.nf/extrapolate. Caloric restriction or just obesity restriction? One important critique of the entire field is that even the most successful studies more likely illustrate the life-shortening effects of obesity rather than the life-extending effects of caloric restriction. The control group animals in most caloric restriction experiments are allowed to eat ad libitum, meaning as much as they want. So maybe any benefits researchers find are less about restricting and more about just not overeating. As anyone with pets knows, if you allow them to eat as much as they want, they can get fat. Middle-aged Labrador retrievers, given unlimited food access in their youth, end up with more than 20 pounds of body fat and only live about 11 years. If you pair litter puppies and restrict 1 to 75% of what their sibling eats ad libitum during that period, they put on less than 10 pounds of fat and live an average of 13 years. 9 out of 24 of the diet-restricted dogs, 37.5%, survived past the time all their unrestricted siblings had died. Is that evidence that caloric restriction is good or just evidence that obesity is bad? Ironically, this aspect of the experiments may make them more generalizable to the human populace. Nearly 3/4, 73.6%, of the U.S. adult population is overweight or obese. So using ad libitum controls may be the appropriate comparator. Those who are very obese, BMI 35 or more, throughout their adult lives lose at least 7 years of life and 19 years of healthy life. Obviously, caloric restriction would be good for them, but most of the restriction experiments don't offer insight into whether someone who was already at a healthy weight would benefit from restricting further. Control group considerations play heavily into the interpretation of conflicting results found in a famous pair of long-term caloric restriction monkey experiments. Monkeying around with dietary restriction. There have been 4 investigations of caloric restriction and lifespan in non-human primates. The particulars are worth exploring, as I do in detail in c.nf/primatecr. But bottom line, if I had to sum up what we've learned from the primate data in one sentence, it would be, if you're overweight or living off junk food, eating less is a good idea. Crony catabolism. What about human data? Lifelong randomized control trials aren't gonna happen, but there have been shorter-term ones. studies of those who calorically restrict voluntarily, as well as a variety of creative approaches to answer the question, does eating less help you live more? For example, do those suffering from anorexia live longer? Far from it. Anorexia nervosa is one of the deadliest mental disorders. Anorexics die at a rate about 10 times that of the general population, suffering from a range of electrolyte abnormalities, anemia, osteoporotic bone fractures, and cardiac arrhythmias. Researchers found that developing chronic anorexia from age 15 would be expected to shave 25 years of a woman's lifespan. Anorexia is an example of extreme caloric restriction. As many as nearly 1/3 of those diagnosed with the disease who seek treatments have a BMI under 15, about half the weight of the average American woman. Unlike laboratory protocols that dictate caloric restriction without malnutrition, those with anorexia may suffer from starvation-related nutrient deficiency so severe that they can go blind. Their contracted lives may therefore not bear direct relevance to the question at hand, not to mention that 1 in 5 anorexia victims die by suicide. The only long-term human study of extreme caloric restriction was the infamous Minnesota starvation experiment that used conscientious objectors as guinea pigs during World War II. Unlike caloric restriction experiments designed to meet recommended daily allowances of essential nutrients, the Minnesota starvation experiment was deficient on purpose. The malnourished study subjects suffered from chronic weakness, painful leg swelling, and severe emotional distress. Interestingly, though, half the study participants went on to celebrate their 80th birthdays, living at least 8 years longer than expected for men in their generation, though other factors peculiar to a pacifist cohort could have played a role. Speaking of unusual groups, self-styled cronies for calorie restriction with optimal nutrition are active members of the Calorie Restriction Society, started by caloric restriction researcher and practitioner Roy Walford. He attempted to popularize the practice in the 1980s with his book, The 120-Year Diet. Sadly, Walford himself died well short of the promised 120 at age 79 of ALS. I review all the research on cronies in c.nf/cronies, spelled C-R-O-N-I-E-S. All in all, long-term practitioners of calorie restriction appear to be in excellent health, but they're a rather unique self-selected bunch of individuals. As always, you don't really know until you put it to the test. Enter Calorie, the comprehensive assessment of long-term effects of reducing intake of energy, the first large, long-term clinical trial to test the effects of caloric restriction. The Calorie Trial. Although the standard caloric restriction diet used in rodent studies is 40% less than the quantity consumed by ad libitum controls, even a 10% reduction can extend the lifespan of rats. Caloric restriction that modest would be amenable to a randomized controlled trial. In the Calorie Trial, hundreds of non-obese men and women were randomized to 2 years of caloric restriction. Details in c.nf/calorie, spelled C-A-L-E-R-I-E. As I mentioned, the study participants in the Minnesota starvation experiment suffered both physically and psychologically. However, the subjects started out lean and had their caloric intakes cut in half. The calorie study ended up being 4 times less restrictive, at only about 12% below baseline caloric intake, and enrolled normal weight individuals, which in the United States these days means overweight on average. As such, the calorie subjects experienced nothing but positive quality of life benefits, with significant improvements in mood, general health, sex drive, and sleep. They also wiped out more than half of their visceral abdominal fat, which translated into significant improvements in blood pressure, insulin sensitivity, triglycerides, and cholesterol levels. During the final year, they were eating only about 300 fewer calories than they had been at baseline, so they got all those benefits after cutting only about a snack-sized bag of chips worth of calories from their daily diets. What happened at the end of the trial, though? In both the Minnesota starvation experiment and experiments on U.S. Army Rangers, as soon as subjects were released from restriction, they tended to rapidly regain the weight, and sometimes more. The leaner they started out, the more their bodies seemed to drive them to overeat to pack back on extra body fat. In contrast, after the completion of the calorie study, even though their metabolisms were slowed by about 100 calories a day, they retained about 50% of the weight loss 2 years after the trial ended. They must have acquired new eating attitudes and behaviors that allowed them to keep their weight down, and did so without any signs of increased susceptibility to eating disorders. Indeed, after extended caloric restriction, cravings for sugary and fatty foods can go down. The slowed metabolism, presented as a quote-unquote reduction in the rate of living, would be expected to contribute to longevity and may explain part of the reduction in whole-body oxidative stress within the first year of caloric restriction. However, even just culturing cells in the blood of those practicing caloric restriction makes them significantly more resistant to free radical damage, perhaps due to a doubling of antioxidant enzyme activity within cells bathed in caloric-restricted blood. Furthermore, two different biomarker algorithms used to calculate quote-unquote biological age found that the caloric restriction intervention appeared to slow the rate of aging, and this appeared to be independent of the degree of weight loss. By one estimate, the ad libitum control group appeared to be aging at an average rate of 0.7 quote-unquote years per year, whereas the caloric restriction group averaged only 0.1. Based on that algorithm, the Clamara-Duval method, the caloric restriction group hardly appeared to be aging much at all. The multitude of physiological, psychological, and aging benefits attributed to the sustained moderate 11.9% caloric restriction must be interpreted with the proviso that the composition of the diet changed along with the quantity. Much of the caloric restriction was achieved through a reduction in fat intake. The type of fat was not specified, but given that the leading sources of fat in the American diet have typically been meat and dairy, followed by desserts like donuts, cookies, and cake, this may have been accompanied by an improvement in diet quality that could account for some of the measured effects. That caveat aside, the calorie trial does suggest that even quote-unquote normal weight individuals should eat less to improve their health and longevity. A sidebar: thinking outside the icebox. Studies following more than 5 million men and women found that abdominal obesity was associated with an increased likelihood of developing cognitive impairment and dementia in men and women older than 65. Caloric restriction has been deemed one of the most effective dietary interventions to improve the cognitive performance of rodents. What about in people? There don't appear to be any human caloric restriction trials for dementia, but there have been about a dozen randomized controlled trials on cognitive effects on those who are cognitively intact or mildly impaired. Although hardly any of the individual studies were able to show significant improvements, when all the studies were compiled together, there did appear to be a cognitive benefit to cutting down on calories. Most of the 1,000 or so study subjects were obese, so the benefit may have derived more from the weight loss than the caloric restriction per se. It doesn't take much, though. When overweight, borderline obese elderly men and women, BMI of 29.9, were advised to reduce their calories by 30% for 3 months, they only achieved about a 12% reduction in caloric intake, losing about 5 pounds, but nonetheless experienced a significant improvement in verbal memory performance. A 12% reduction is what the calorie intervention group participants averaged. At the end of 2 years, they had better working or short-term memory than those randomized to the control group. Interestingly, the cognitive improvement was related mostly to lower protein intake. This was tested directly in a study titled Dietary Effects on Cognition and Pilots' Flight Performance. Commercial airline pilots were randomly rotated through 4-day high-carbohydrate, high-protein, high-fat, or control diets. Then they had their flying performance evaluated using a full-motion flight simulator. Compared to being on any of the other 3 diets, when the pilots were on the high-protein diet, their flight performance suffered. More extreme fasting appears to have rather equivocal effects on cognition in the short term. Those randomized to eat nothing for a day subjectively feel greater quote-unquote mental fatigue than those given about 500 calories of food throughout the day, but they perform just as well on objective tests of cognitive performance. Given the potential for psychological influence, there was actually a randomized, double-blind, placebo-controlled trial of 48 hours of caloric deprivation. How can you blind someone to whether or not they eat? They were fed indistinguishable gels, either nearly calorie-free or providing thousands of calories a day. Surprisingly, 2 days of near total caloric deprivation did not affect the cognitive performance, activity, sleep, or mood of healthy young adults. This makes sense from an evolutionary point of view. Remaining sharp during a downturn in food availability would presumably offer a survival advantage. Potential downsides of caloric restriction. Caloric restriction has been heralded as a fountain of youth. The near universal benefits seen in the calorie trial support the potential health and longevity benefit of mild caloric restriction without the downsides seen with more extreme restriction, like loss of libido, strength and bone mass, menstrual irregularities, infertility, cold sensitivity, slow wound healing, blood pressure dropping too low, and psychological conditions such as depression, emotional deadening, and irritability, not to mention walking around starving all the time. Two of the most serious pitfalls, impaired wound healing and recovery from infection, could possibly be restored sufficiently by temporarily resuming a full diet in the event of injury or illness. Full wound healing capacity was re-established in calorie-restricted rats and mice within days or weeks of full feeding, but the refeeding was done before the wounds were inflicted. This could be useful in the case of scheduled surgery, but may have limited relevance to spontaneous injury. One might presume that immune suppression could result from steroid stress hormones released in an underfed state, but although total fasting can dramatically increase cortisol levels, as much as doubling them within 5 days, less severe caloric restriction does not. Though many indicators of immune function improve during caloric restriction, this doesn't necessarily translate into improved survival from infection. Despite an apparent rejuvenation in immune system parameters, when actually put to the test, feeding rodents 20 to 40% less than ad libitum intake has been found to have detrimental impacts in fighting bacterial, viral, fungal, and parasitic infections. Refeeding calorie-restricted mice 2 weeks before influenza infection improved survival back toward the level of normal-fed mice. For those without crystal balls, the researchers suggest unrestricting caloric intake before or perhaps throughout the flu season. One of the most consistent benefits of caloric restriction is improvement in blood pressure in as short as 1 or 2 weeks. Unfortunately, this can work a little too well and cause orthostatic intolerance, manifesting as lightheadedness or dizziness upon standing, which in severe cases can cause fainting. Staying hydrated can help. What about loss of muscle mass? Unintuitively, caloric restriction appears to actually delay age-related muscle loss in rats and monkeys. Details in c.nf/restriction pitfalls, but in the calorie trial, participants generally got stronger. There was also a small increase in aerobic capacity in the restricted group compared to control. Increased protein intakes are commonly suggested to preserve more lean mass, but most studies fail to show beneficial effects on preserving muscle strength or function, whether young or old, active or sedentary. And high protein intake during weight loss has been found to have quote-unquote profound negative metabolic effects, undermining the benefits of weight loss on insulin sensitivity. Lose 20 pounds, and you can dramatically improve your body's ability to handle blood sugars, compared to a control group who maintained their weight. Lose the exact same amount of weight, but on a high-protein diet, getting an extra 30 grams a day, and from a blood sugar control standpoint, it's like you never lost any weight at all. Though you can always bulk back up afterwards, the best way to preserve muscle mass during weight loss is exercise. Resistance training, even just 3 times a week, can prevent more than 90% of lean body mass loss during caloric restriction. The same may be true of bone loss. Lose weight through caloric restriction alone, and you experience a decline in bone mineral density and fracture risk sites like hip and spine. However, in the same study, those randomized to lose weight with exercise didn't suffer any bone loss. It's hard to argue with calls for increased physical activity, but even without an exercise regimen, the quote-unquote very small drop in bone mineral density in the calorie study might only increase the 10-year risk of osteoporotic fracture by about 0.2%. A high-resolution MRI study of the bones of cronies found a reduction in bone quantity, but not bone quality. The honeycomb-like microarchitectural structure within the bone appeared to be preserved despite the reduction in bone mass. A sidebar: chipping away at pollutants? Body fat may play a protective role by sequestering toxic pollutants, such as PCBs and DDT, which comes spilling out when we lose weight. Now, that's one of the reasons health authorities recommend that women don't try to slim down during breastfeeding. I cover the ways in which we can protect our vital organs in c.nf/fasting detox. Eating Pringles made with the fake fat olestra doesn't seem to help, but fiber can bind to these pollutants and potentially flush them out of the body. Check out c.nf/eat low for ways to prevent the buildup of industrial toxins in the first place. More food, less calories. The bottom line is that the benefits of mild caloric restriction revealed by the calorie trial, improved blood pressure, cholesterol, mood, libido, and sleep, would seem to far outweigh any potential risks. The fact that a reduction in calories seemed to have such wide-ranging protective effects led commentators in the American Medical Association's Internal Medicine Journal to write, quote, "The findings of this well-designed study suggest that intake of excess calories is not only a burden to our physical homeostasis, but also to our psychological well-being," unquote. This is all the more remarkable given how little they were actually restricting. By the end of the 24 months of the calorie trial, the caloric restriction group was eating just 100 fewer calories a day than the ad libitum control group, a slip in compliance from the 200 or so fewer calories a day at the end of the first year. A common refrain from commentators is that all this benefit can be yours by skipping your daily latte or cutting your muffin du jour in half, but by switching to healthier foods, you can achieve the same caloric reduction while eating more food, not less. The reason obesity rates among vegans may run as low as 2 to 3% is that those eating more plant-based eat as many as 464 fewer calories a day while eating the same amount of food or even more. That's the beauty of foods with low calorie density. More food, less weight. For an in-depth discussion of caloric density, please see my book, How Not to Diet. The founding director of Harvard's Center on Aging Research, David Sinclair, wrote, quote, "After 25 years of researching aging and having read thousands of scientific papers, if there's one piece of advice I can offer, one surefire way to stay healthy longer, one thing you could do to maximize your lifespan right now is this: eat less," unquote. Eating fewer calories, however, doesn't necessarily mean you have to cut portions. For example, part of Okinawans' longevity may be because they were only eating about 1,800 calories a day. However, because whole plant foods are so calorically dilute, they were actually eating a greater quantity of food. Intermittent fasting. Rather than cutting calories day in and day out, what if instead you just ate as much as you wanted every other day? Or for only a few hours a day? Or what if you fasted 2 days a week or 5 days a month? These are all examples of intermittent fasting regimens, and they may even be the way we were built to eat for millennia. Our ancestors often may have consumed only one large meal a day or went several days at a time without food. Might intermittent fasting stress our body in a good way, like exercise, through hormesis? Mark Twain thought so. Quote, "A little starvation can really do more for the average sick man than can the best medicines and the best doctors. I do not mean a restricted diet, I mean total abstention from food for 1 or 2 days," unquote. But Twain also said, quote, "Many a small thing have been made large by the right kind of advertising," unquote. Is the craze over intermittent fasting just hype? I cover all the important studies on alternate day fasting in c.nf/alt-day-fasting, and 5-2 fasting, eating 5 days a week, in c.nf/52fmd, which is the numerals 52, then FMD. The bottom line, there do not appear to be any advantage over chronic daily restriction, and as I discuss in c.nf/alt-day-safety, the largest and longest trial of alternate day fasting disturbingly found a significant increase in LDL cholesterol. One study of postmenopausal women also found that intermittent caloric restriction led to twice the loss of lean body mass compared to weight loss from chronic restriction. I also caution diabetics and those on medications, though concerns about mood, cognition, and eating disorders have been eased. Symptoms of irritability and inability to concentrate on fasting days may wane over time, and of 11 interventional studies, although 4 showed an increase in binge eating, 2 showed no change, and the other 5 showed decreases in binging. Intermittent fasting and longevity. Most intermittent fasting studies focus on weight loss. What about life extension? Mormon teachings call for a once-monthly fast when adherents are expected to skip 2 consecutive meals, thereby fasting about 24 hours. Could this play a role in Utah routinely having among the lowest rates of death due to heart disease, and help explain why men active in the Mormon Church have tended to live about 7 years longer than the U.S. average? In a study of a cardiac patient population with a preponderance of Mormons, routine fasters were found to have lower rates of diabetes and severe heart disease. Does this translate into living longer? About 2,000 patients in a medical center in Salt Lake City were followed for 4 years after cardiac catheterization. About 400 were routine fasters, adhering to the monthly practice of an average of 42 consecutive years, about two-thirds of their lives. Did they do better than their non-fasting colleagues? Yes, they had a 46% lower risk of dying in the subsequent years of follow-up. The obvious confounding would be other tenets of religious observation. Those following Mormon teachings on fasting to the letter might be more likely to follow other doctrines of the church, and indeed routine fasters were significantly less likely to smoke and significantly more likely to be teetotalers. However, both of these factors were taken into account, and the survival benefit remained. What they didn't control for, though, is diet composition. In addition to monthly fasting, the Mormon Church recommends consumption of whole grains, fruits, and vegetables, with meat only to be eaten, quote-unquote, sparingly. Hence, it's not clear how much of the survival advantage among the fasters was due to the quality of their diets rather than the periodic dips in quantity. The only way to prove cause and effect is to put intermittent fasting to the test, which it was, remarkably, in the 1950s. Inspired by the data being published on life extension with caloric restriction on lab rats, researchers split 120 residents of a senior home in Madrid into two groups. 60 residents continued to eat their regular diets, and the other 60 were put on alternate day modified fast for 3 years. Details on the study and its outcomes are in c.nf/fasting longevity, but basically it's held up as evidence that caloric restriction may improve one's health span and potentially even one's lifespan, given that there were approximately twice as many deaths and hospitalizations in the control group. But, as I explained in the video, serious caveats are in order. Fasting mimicking diet. Instead of 5-2, what about 25-5, spending 5 days a month on a quote-unquote fasting mimicking diet? Longevity researcher Walter Longo designed a 5-day meal plan to try to simulate the metabolic effects of fasting by being low in proteins, sugars, and calories, with zero animal protein or animal fat. By making it plant-based, he was hoping to lower the level of the cancer-promoting growth hormone IGF-1 related to animal protein consumption, which he accomplished, along with a drop in markers of inflammation after 3 cycles of his 5 days a month program. Check out c.nf/52fmd, just the numerals 52 then FMD, for the pros and cons. Dr. Longo created a company to commercially market his meal plan, but says, to his credit, that he donates the profits to his nonprofit research foundation. The whole diet, so-called Prolon, appears to be mostly a few dehydrated soup mixes of vegetables, mushrooms, and tomatoes, herbal teas like hibiscus and chamomile, kale chips, nut-based energy bars, an algae-based DHA supplement, and a multivitamin dusted with vegetable powder. I figure, why spend $50 a day on a few processed snacks when you could instead just eat a few hundred calories a day of real vegetables? Time-restricted eating and longevity. What about fasting a little bit every day? The reason many blood tests are taken after an overnight fast is that meals can tip our systems out of balance, bumping up certain biomarkers for disease such as blood sugars, insulin, cholesterol, and triglycerides. Yet fewer than 1 in 10 Americans may even make it 12 hours a day without eating. Might it be beneficial to give our body a bigger break? Time-restricted eating is defined as fasting for periods of at least 12 hours, but less than 24. In c.nf/TRE, I present evidence that early time-restricted feeding, a narrow eating window shifted towards the morning, carried a variety of metabolic benefits. For example, as I profiled in c.nf/early-TRE, those randomized to stick to a 6-hour eating window ending before 3 p.m. experienced a drop in blood pressures, oxidative stress, and insulin resistance, even when all the study subjects were maintained at the same weight. The average drop in blood pressures was extraordinary, from 123/82 down to 112/72 in just 5 weeks, comparable to the effects of potent blood pressure-lowering drugs. As I note in c.nf/early-TRE, studies suggest that prolonged nightly fasting with reduced evening food intake may decrease cancer risk and recurrence, and may even play a role in the health of perhaps the longest-living population in the world, the Seventh-day Adventists in California. Slim, vegetarian, nut-eating, exercising, non-smoking Adventists live about a decade longer than the general population. The greater life expectancy has been ascribed to these healthy lifestyle behaviors, but there's one lesser-known component that may be playing a role. Historically, eating 2 large meals a day, breakfast and lunch, with a prolonged overnight fast was a part of Adventist teachings. Today, only about 1 in 10 Adventists surveyed were eating just 2 daily meals, but most, 63%, reported breakfast or lunch as their largest meal of the day. A study of older Italians found that those who had a food window that was narrower than 10 hours a day had 72% lower odds of suffering from cognitive impairment. However, this was limited to those practicing early time-restricted feeding, meaning not skipping breakfast. In general, shifting food intake towards the morning, eating breakfast like a king, lunch like a prince, dinner like a pauper, or skipped entirely, has beneficial cardiometabolic effects, whereas the same eating window pushed towards the evening, meaning skipping breakfast, can have null or negative effects. Don't try this at home. What about periodic longer fasts? Proponents speak of fasting as a cleansing process, but some of what they're purging from their body are essential vitamins and minerals. In C.NF/fasting safety, I cover the very real risks of prolonged fasts. Contrary to the popular notion that the heart muscle is specially spared during fasting, the heart appears to experience similar muscle wasting. Breaking the fast appears to be the most dangerous part. After World War II, as many as 1 in 5 starved Japanese prisoners of war tragically died following liberation. Now known as quote-unquote refeeding syndrome, multi-organ system failure can result from resuming a regular diet too quickly. Medically supervised fasting has gotten much safer now that there are proper refeeding protocols. We know what warning signs to look for, and we know who shouldn't be fasting in the first place, such as those with advanced liver or kidney failure, porphyria, uncontrolled hyperthyroidism, and pregnant and breastfeeding women. Fasting for longer than 24 hours, and particularly for 3 or more days, should only be done under the supervision of a physician, and preferably in a live-in clinic. This is not just legalistic mumbo-jumbo. For example, your kidneys normally dive into sodium conservation mode during fasting, but should that response break down, you could rapidly develop an electrolyte abnormality that may only manifest with nonspecific symptoms like fatigue or dizziness, which could easily be dismissed until it's too late. A sidebar: fasting for cancer treatment. Short-term fasting before and immediately after cancer treatment can minimize side effects while, at the same time, may actually make cancer cells more susceptible. I review the preclinical studies in C.NF/fasting cancer, including experiments showing how fasting can mean the difference between 100% of animals dying versus 100% surviving. In C.NF/fasting chemo, I run through the clinical trials. Water-only fasting for a total of 72 hours before and after chemo appeared to reduce the toxicity of treatment without detectable harm. Fasting-mimicking diets have also been tested. In the DIRECT trial, which is dietary restriction as an adjunct to neoadjuvant chemotherapy, more than 100 breast cancer patients were randomized to the same sort of plant-based, low-calorie, low-protein, and low-carbohydrate fasting-mimicking diet of mostly soup, teas, and broth for 3 days before and a day after each chemotherapy cycle. Unfortunately, there was no difference in quality of life or chemo side effects between those randomized to the fasting-mimicking diet or those in the regular diet control group. However, a per-protocol analysis did find benefits, meaning that if you took compliance into account and only counted those who actually followed the instructions and stuck to the diet, they did significantly better across a range of emotional and physical function scores. Isn't that what we care about? What happens when you actually do it? The problem with per-protocol analyses is that we lose the bias-busting power of randomization. For example, maybe people who felt better in the first place were more likely to stick to the program. Quality of life aside, did the fasting-mimicking diet make the chemo work any better? Fasting-mimicking diets appear to help control cancer in mice, and a series of promising human case reports have been published. But what happened in the DIRECT trial where it was actually put to the test? There was no significant difference in the most important measure, complete response rate, the disappearance of all signs of cancer from the body. That occurred in about 11% of cases in the diet group versus 13% of cases in the control group. There was, however, 3 times the rate of radiological evidence of tumor shrinkage on MRI or ultrasound in the diet group, though the impact of this on long-term outcomes is uncertain. In the per-protocol analysis, there was also an improvement in pathological response, the disappearance of cancer cells in surgical specimens, though as with any per-protocol analysis, this carries the potential for selection bias. The lack of any robust evidence of benefit has been blamed on the lack of compliance with the fasting-mimicking diet regimen, which was attributed mainly to the dislike of certain prepackaged components, a suggestion was made that future trials consider incorporating fresh foods. Lowering IGF-1 with dietary restriction. Is there anything we can tweak in our diet to get similar benefits without having to fast? As I elaborate in c.nf/fmdcancer, one of the ways fasting works is by reducing the levels of the cancer-promoting growth hormone, insulin-like growth factor 1, as I've talked about before. Reducing levels of IGF-1 appear to mediate the differential protection of normal versus cancer cells in response to fasting, because the restoration of IGF-1 can be sufficient to reverse the protective effects. Add chemo to various types of cancer in a petri dish, and half or more of the cancer cells can be wiped out. Under starvation conditions, the same dose of chemo can wipe out twice as many cancer cells in a petri dish, but this effect vanishes when IGF-1 is added back to the mix. The downregulation of IGF-1 through fasting is conceptualized as a way of turning anti-aging genes against cancer. If you remember, the lowering of IGF-1 levels, genetically or otherwise, can lead to a significantly longer lifespan. But fasting isn't the only way to drop IGF-1. Yes, a few days of fasting can cut levels in half, but that's largely because you're cutting your protein intake. Protein intake is considered a key determinant of circulating IGF-1 levels in humans, suggesting that some of the anti-cancer and anti-aging benefits of eating less food could be captured by just eating less protein. In rodents, caloric restriction alone can reduce IGF-1, but in people, just cutting down on food in general isn't enough. For example, in the calorie trial, 2 years of caloric restriction didn't lower IGF-1 compared to the control group. This isn't surprising, since there was no concomitant drop in protein intake. Even severe caloric restriction doesn't decrease IGF-1 levels unless protein intake is also reduced. Cronies, practicing about a 30% caloric restriction for an average of 6 years, had IGF-1 levels similar to those eating a full standard American diet. Again, no surprise, as the cronies were eating 1.7 grams per kilogram protein a day, twice the recommended dietary allowance of 0.8 grams per kilogram. In contrast, a group of vegans eating right around the RDA for protein had about 25% lower IGF-1 levels in their blood. This was assumed to be due to the protein difference, since interventional trials show increasing protein intake increases IGF-1, but how can we be sure it's not some other factor? By putting it to the test. And indeed, when cronies eating 1.7 grams per kilogram of protein dropped their intake to 1 gram per kilogram or less, within 3 weeks, their IGF-1 levels dropped by 25%, on par with the vegans.